Welcome and good morning to Advent of Code day 13. Distress signal. You climb the hill and again try contacting the elves. However, you instead receive a signal you weren't expecting, a distress signal. Your handheld device must still not be working properly. The packets from the distress signal got decoded out of order. You'll need to reorder the list of received packets. Your puzzle input to decode the message. Your list consists of pairs of packets. Pairs are separated by a blank line. You need to identify how many pairs of packets are in the right order. For example, then we have some sub packets somehow. We'll see. Packet data consists of lists and integers. Each list starts with a bracket, ends with a closing bracket, and contains 0 or more comma separated values, either integers or other lists. Each packet is always a list and appears on its own line. Packet data consists of each packet is always a list and appears on its own line. Okay. When comparing two values, the first value is called left and the second value is called right. Then, if both values are integers, the lower integer should come first. If the left integer is lower than the right integer, the inputs are in the right order. If the left integer is higher than the right integer, the inputs are not in the right order, otherwise the inputs are the same integer. Continue checking the next part of the input. If both values are lists, compare the first value of each list, then the second value, and so on. If the left list runs out of items first, the inputs are in the right order. So left list must be shorter. If the right list runs out of the items first, the inputs are not in the right order. If the lists are the same length and no comparison makes a decision about the order, continue checking the next part of the input. If exactly one value is an integer, convert the integer to a list which contains that integer as its only value, then retry comparison. For example, if comparing an array of 3 zeros and the number 2, convert the right value to an array containing the element 2. The result is then found by instead comparing the array of 3 zeros and the array of a 2 containing the element 2. Using these rules, you can determine which of the pairs in the examples are in the right order. 1, 1, 3, 1, 1 versus 1, 1, 5, 1, 1. Compare the 1, compare the 1. Compare 3 versus 5. Left side is smaller, so inputs are in the right order. Okay, and then we're done with this list. Then more complicated, list of lists, not 1 versus 1, compare 1 versus 1, that's still fine. Then we compare 2, 3, 4 versus 4, which has mixed types, so we convert the 4 to an array and retry the comparison. Then we compare the 2, 3, 4 versus 4, and this means we compare 2 versus 4, which is technically correct, but the left side is smaller for the first element and are in the right order. But because, pair 9 versus longer double listed list, nested list, mixed type, we convert the 9 to the array, and then retry, and 9 is 9 versus 8, so the right side is smaller, so inputs are not in the right order. Okay. And then for compare 4, we compare 4, 4, 4, 4, 4, 4 versus that. 4 is, this is all the same, that's fine. Then we compare 4 against 4. And then the left side runs out of items, so the inputs are in the right order. And then we have the same with 7, missing the sublist. Inputs are not right. And an empty list. Left side ran out of inputs items, so inputs are in the right order. And this is also interesting. We would check this list versus this list. The right side then ran out of items, so inputs are not in the right order. What are the indices of the pairs that are already in the right order? The indices of the pairs that are already in. The first pair has index 1, the second pair has index 2, and so on. In the above example, the pairs in the right order are 1, 2, 4, and 6. The sum of the indices is 13. Determine which pairs of packets are already in the right order. What is the sum of the indices of those? Okay. Okay. So and this is our input, and we have day 13, new directory 13, just copy over that. And we have, which is 13. And we also get our input, which is a bit longer. Not bad. So, I don't need that. Then we'll create our puzzle. So then we'll have var line index, which starts at 0, and then we'll create the var. This is pair index, also starts at 0, and then we just go while line index is smaller lines dot length or size, and we want to have a data class which represents our pair, and in this pair we would have data class would call this actually expression, and the expression itself has so it knows if it's a list or an we can call it, we can just put a sub, and this is a list of expression, yes, and this list of expressions, and we would also have yeah, we can make this null, but we would also have a val which is element, which is an integer, but it's nullable, and we would check val is element, and we can check this with element is equal to null, is not equal to null, and we can also have val element get. And then we would also I want also have a function which is wrap, which would basically just return we can check. I'm not really sure if we would ever wrap a list. I think we don't, so that's why I checked the is element here. This returns an expression, and I would return an expression where I set this to null, and the sub will be set to this list of. Then we could wrap this, and then would think we can already start trying to do the comparison method. Compare B, and the easiest case is A. This is element and B is element. If that is the case, we can just we only need to know if the order is correct, so let's call it check, return a boolean here. And in this case, I would say if the element and both are elements, then this is correct. If element is smaller, equal b dot element, those now could theoretically be null, right? Yeah, but we've actually already checked that they aren't, so this is fine. Then we have the case that we can wrap both, or we would wrap both. So we would have the case that both of them are with each element. We can also have each list. Then we have the exact opposite. Yeah, let's first deal. So this is clear in that case to return this. But if either of them is an so if this is an element, then we would say this dot wrap. If B is an element, we would wrap the B element, val AL, val BL. else this, else it stays the same. And now we can start comparing lists, and we'll have we would compare those lists by just looping over them, both with the same index. So var al dot sub. Is there something like zip? I'm a bit unsure what it will do if they're not the exact same size, so we'll do it by hand. 0. While index is smaller than al.sub. This dot, it's wrapped then, but then we actually only care about the subs. Don't really care about. So if I, let me just think, does it make sense to actually wrap them at all? Because we then only compare the subs? Yeah, not sure if this really makes sense then, but yeah, I think that's a bit. Yeah, we could do this more optimized, but yeah, don't really care. And index size bl.sub.size, and we would return if our al.sub at position index would be larger than bl.sub at the position index. And we can actually check this. So if this check here would be positive, then we are fine. If this check is negative, we will return false. If we come to the end of this loop, we will return al.sub.size is smaller. I'm not sure if lists are exactly the same length. bl.sub.size, then they are in the correct order, but then they also have no difference in the yes. So we will return if this is smaller or equal than bl.sub.size. And what we obviously have forgotten here is index plus plus. Okay, so do we want to keep both expressions, yeah, well, A expression, val B expression, and we keep a pair index, index int but I have not really parsed the expression by now, right? Yes. That's absolutely true. So that means we can add a parsing for this. This is the check, so then we companion object will fun from string so then so how does our input look like? It looks like this. So I would say str find first or this substring after I'll get those parts, then I get my str. This will get a substring start and end index. The end index is usually excluded. So I would val start is this, val end is this. I will take start +1 and I will take end. Then this is my part. This will take the most out of brackets, then I'm fine. And I will send whatever is in there to the next method. The problem is only if I get something with two lists. If I would get, for example, something like this here, I would not be allowed to take the and I can't split by comma here already. So um, yeah, we have a nice formatting here. So I would actually say we'll take the start and we'll find let's give this a try. Teacher. So we'll take our string, add position index, and check if this is equal to the opening bracket. If we have an opening, zero. Yeah. Then we'll want to open another context. Then we have if our index is, this is not the case, then we want to do a from string, which will give an expression. Do we want to do any parsing then? Yeah, well, then we detected an opening of a list, so we know we'll need to declare a list here. But the do we have a useful data structure for doing? Well, if our start index is that, then I would just say we have, yeah, give it a try. We'll declare a list of just add the characters as long as we don't. Until when do we just add the characters? Does this even make sense? Until the next bracket. How do we, with which symbol do we start? This won't work. Figure that out, unfortunately. But we want to go down. If we say parse to something like this, we will open we can't take the last one, right? No, I would just say then from string and would parse in index +1. A bit unsure. But if we at some point then encounter then we want to send and if we encounter this, we actually want to do the return. We would like to return the expression we just collected. We also need to return how many elements we could we do this with a stack? Mm-hmm. Stack. No, the first one is a list. And we can, I think, just say substring 1 and str.length -1 var current. And then I would just say if we'll iterate over this for C in cropped. Still a bit unsure. And if we read this one, then we say dot then we need to add a new expression of null and a mutable list of. And it would be fine with that. If we read a closing one, we can know that our expression dot remove first is our current sub. And we could say expression stack dot first dot sub dot add isn't sub, it's a mutable list. Yeah, okay. Current sub. This one would always wait for now be C. And in case we are reading a number, let's start with this. We create another sub expression, and then we read a number. So if we read anything, well, we will handle the number last, I would say. The number would be the else, and we would just concatenate it for now. Numbers can't be mixed with others, so I would keep something here like a number buffer, which is empty for now, and the number buffer would just append the C, the current character, and an opening bracket can't basically come here, so we shouldn't have that. For the closing bracket, that can be the case that the number buffer hasn't been flashed. So what we will do is we'll take we already have the current sub expression here. we would say current sub expression number buffer empty list number buffer to int. But we could also read the have a character comma. In case of the comma, we would actually do the same. Except that we would not remove the first, we would just get the first. This can also be else if. The only thing I now am a bit concerned of is the current. Do we do this right here? So whenever we read the comma and our number buffer is not blank, then we would do this. If you just read a comma after a list, we would be, well, we're just fine. Nothing happens. The list is taken care of. And I think we'll also should put, or need to put this here, if our number buffer is not blank. The only thing is, I'm not so sure if we would, but I think for now we so yeah, cool. And then I would return the root here. Not 100% sure if this parsing works, but what we can do is we can. I actually wanted to do a toString function here from a to original string, which would return a string, and I'd actually like to let me just think of if this is an element. If we are an element, then we return turn element to string, else we will return that's the thing, this stupid list. We should make it nullable. We need to know if it's an empty. We would like to know if it's an empty list. I'm not sure if we need to, but we'll put this for null for now. And make this nullable. Do we have any issues with that? We have issues here. Because sub might be null. Yeah, fine for me. It shouldn't. But if we add the number here, this should be null. I mean, if we are a number, it might not matter, but no, if we just do it, I think we can keep it. we anyhow know it for the character what kind of thing we are, so I think we can revert this. Don't need to keep double track of it. And then we would return the sub dot join to string. The separator would be the comma, and we would add the bracket here, and we would add the bracket there, and we would subjoin this, but actually we would sub.map it to original string. Yeah. And then for the toString, I would go there, root, and would say check root equals line I think this actually doesn't really make sense. Well, I create a root expression here. This is absolutely fine. But this element will put the last one, create the first one on the stack, and this one would. I'm a bit unsure how it would affect if I could have the root element. That's why I'll keep it outside for now and remove the first brackets. Root equals, or root dot or to original string should be equals the str and actually also our expression stack should be empty. Check expression stack is empty. Would set the debugger here, so we now should have the from string line inline index. We will have line index plus equal to, and the pair index plus plus plus, and we will say line at line index. I can just do it like this, then I can save on that. We would say val a is equal to expression dot from string. And if we have that, I would create a pair where I would insert the A and the B and the pair index and we and then we would have here our val list of pairs is list of pair, and with the list of pairs dot add this, And we can now say list of pairs dot filter it dot a dot check against it dot b, and then we could say the sum of it dot index. But the pair index starts counting by 1, if I'm not mistaken, because reasons. And this can be the sum. And we would just return sum to string. So unfortunately, I can't say that I'm confident this will work now. But we'll see. Yeah, that would actually be my I need to know the last root element, and this would kinda get lost with the last one. But we can't do the following. We could actually still just set it, because if we take the str here, forget about that stuff, and yeah, this. Yeah, well, it would be on the stack, wouldn't it? Would it stay on the stack? No, it wouldn't, because it would be removed here. Well, no, I think that's absolutely fine if we do it like that. The only thing what we also need to do is we need to add first root. I think we just need to add root. Then we can just check if this is, it shouldn't be empty now, but I can check this dot first is equal to root. They should be the same. So then let's give it another try. Expression stack is of size 1. I'm not absolutely sure if this would work. This is even true. And now this gets interesting. I would say this makes absolutely no sense. Oh, yes. Well, the current, let me just check, is not blank, blah, blah, blah. We have the number buffer here. And if we do that, we need to clear it. And we'll need to do the same if we do this here. So 1 1 3 1, but we're missing a 1. The string contains it, right? So we didn't clear the last number buffer, which, well, we can either do this at the end. Well, we can now run into an open end like this because we don't have the closing bracket. This would be then the last one. Or we can just create an artificial root. Still nicer it would be if we'll create an artificial root, so we don't do this. Just do str. We call this fake. Call this root, but we actually and the stack should only contain one element. That's still the case, except this is all the case. That's all fine, but we want to take the root.sub.0. And we would also like to return this, I think. Our expression stack has an element. It is one sub. And I would like to see this representation. 331, that's fine. And I also want to check actually that the number buffer must be empty. Is blank. Then let's give this a try. This is true as well. Very nice. So let's rerun this. Not so cool. Root error with that. Root string check error. And this is number buffer. This already. Yeah, then root.subs is not empty. I'm passing empty lines here. this is the idiotic thing. Yeah. Blah blah blah. Pair index plus line index plus plus. Number buffer can actually contain a comma character. Well, if the number buffer is not blank. Yeah, only if the number buffer is not blank. Not for here, I still need to consume the character. But yeah, but this is only if the number buffer isn't blank. Because we can obviously have it that can actually check this here. If we do this, the number buffer needs to be blanked, and also if we read no, not like this. Yeah, we can run. Yeah, good for now. No, well, why not? It needs to be blank. Just have the $C here, which is not the index, which is a bit annoying, but okay. C in $str. Yes, and we don't need to reset it if it's blank. Good. So then run it again. But it seems parsing now works. Let's check our list of pairs if they are actually, at least we come to that point. Let's check our list of pairs. List of pairs. We can just override fun toString here, I think. Then I would do the same here. We can just do the same for here. And I would just want to have it a toString plus \n plus b toString return. And then we could just take our, well, I think we should be fine, but toString. And our list of pairs, evaluate expression. We can just wait for fun check boolean check b. Just list of pairs for each println it the first one, right order, not. The second one is already in the right order, but we are not doing that correctly. Let's figure that out. So we take, let's set the debugger here. And now we should have time. So I would say F9. Second one is wrong, right? The third one is not correct, but it should not be correct. The fourth one is correct. The fifth one is not correct. 777 is not correct. Empty list in 3 is correct. The seventh pair is not correct. And the last one, the pair 8, is not correct, which we'll also have like this, right? Yeah. So then F9. This is the first one. We know that this works. And now it gets interesting. So we now are checking. This is 1, 2, 3, 4. And the first check is if both are not elements. They aren't. Then if we need to wrap something, we don't need to. And then we should start comparing those 1 and 1 sublists. Index is smaller of both. Should go into that. And now we'll take the first element of A and the first element of B and check them. And if they are true, yeah, this is actually a dumb idea. This check is actually wrong. No, if they are true, this will be false and will be happy on, right? So, so we go into this check method, and we would now expect to have an expression B, which is 1, and we'll have this, which is also 1. And those two should match. Both of them are not an element, that's correct. But both of them are lists, so none of them gets wrapped. Then we do another check, and now both of them are expected to be elements. Element is smaller or equal element B. We would get a true. This means a false here. This means we don't go into there. And we'll increase our index. This means we are out of both indices. We have a size of 1 here, and we have a size of 1 here, which is perfectly fine. We're now back another iteration, and we're now checking the next sub-element. And sub-element with... No. Me confused. We had sub-elements. Yeah, well, we have checked this. This should be a true. We should not go into this false. So we should now arrive at the next check. And this sub-element is 2, 3, 4. And we would have the 4 on the other side. Yeah, I know. And we would now expect a mixed type, and we would convert this. So... not both of them are elements. The A is an element. It should not be wrapped. The B will be wrapped. And we expect to have an is element no with a sub of the 4. We now check this element. And those elements this condition will be true. Yeah, and we will now check this condition is true. That's absolutely fine. If we've passed this, actually, two compares to left side, so we have this early abortion. Yeah, we abort here early, which is perfectly fine. So the longer list can be in front of as long as both are integers. The lower integer should, if both values are lists, compare the list, the first value each list, then the second value, and so on. If the left list runs out of elements first, the inputs are in the right order. If the right list runs out of items first, the inputs are not in the right order. If the right list runs out of items first, the inputs are not in the right order. To compare the first value of each list, then the second, and so on. If the left list runs out of elements first, If the list runs out of items first, the inputs are in the right order, which is not the case for us. Hey. Do I only continue if there is not a... Yeah, okay. So this then would be correct for one element. Mm-hmm. So this is actually a tie. It would actually be a tie. Mm-hmm. Then let's do it like this. Then let's make this an integer. Don't know if it matters. Then if we do this check here and we end up this check is greater 1. I say a minus b, so if a is larger, we will get a value greater 0. And if we receive a value greater 0, we have failed the check and we will return also a value greater 0. And as long as this is the check result, and then we still keep checking, but we'll receive a value if a is greater 0, this value will be greater 0. And that would be wrong. If the value here is greater 0, it would be wrong, and if left runs out first, it's correct is this is smaller equal 0. Yeah. Smaller equal 0 is correct, so we still have the same shit going on, which can be good or not. No, we would actually want to abort this, not if we fail. When this is the first time this is correct, when this is smaller 0, then we want to return with -1. As far as I've understood. We just keep checking a list if we do that. And if this is never the case, well, and if this is the case, yeah, we can have this, the check result is equal to this. If check result is larger than 0, can just also say unequal to 0, because then we can just return it. Okay. Now you just need to put all of the packets in the right order. Disregard the blank lines in your list of received packets. The distress signal protocol also requires that you include 2 additional driver packets. Using the same rules as before, organize all packets, the ones in your list of received packets as well as the 2 divider packets, into the correct order. Divider packets. 2 additional divider packets. Afterwards, locate the divider packets to find the decoder key for this distress signal. You need to determine the indices of the 2 divider packets and multiply them together. The first packet is at index 1. The second packet is at index 2 and so on. To find the decoder key for this distress signal, you need to determine the indices of the 2 divider packets and multiply them together. Yeah. The first packet is at index 1. The second. Okay, so index are based on 1. In this example, the divider packets are 10th, 14 at 10th and 14th position, and the decoder key is 140 because they are multipliers. Okay. Okay. So for our example input, we additionally include those 2. And for our example check, we will change this to 140. And yeah. Fine so far. Then let's go to our puzzle input here. Just just move that up here. Let's close this, add this, and remove one here. And this is the only thing we actually get from this, so we can call this parse pairs. And in this, fine for now, we can leave this inside here. And we'll just copy over this. And we will just return a list of expressions. Our input will still be the same, right? Yeah. If I go, this was a bad idea because we need to anyhow add them. Because our input is still like that, I would just exchange this here for a list of expressions, and would just add A, add B, remove the pair index, call this list of expressions. It should be fine here. And we would have a list of expressions. And we can create val. Do we know which one is the start? Well, we kind of know. Do we really care? Not really. Expression from string. Check, check. And the 2. And the 6. Which is then the end. Then we take the list of expressions. What we can now do is, we don't need the pair, but we have this nice check function, and I think we can say comparable with expression. Then it will ask us to implement the compare to. The compare to function is should exactly be our check function, other return. And we would have our list of expressions here. We will, of course, we made this not mutable. Add start at the end. List of expressions that's sorted. Can we say sort? We can also say sort. List of expressions dot find index of. Can we do something index of first where it's dot index of start, index of end, and we want to have both positions +1, +1. And then we want to say val p start, val p end, and that for now. And then we return just p start times p end. So let's use the part 2. And hope I just modified the part 2. Yeah, let's set. Maybe this is just correct. And it is. Very good. Yeah, nice. Took us 1.5 hours. Think quite adequate for day 13. Still could have been faster. Did not so much like the description of part 1. Got a little bit confused why they put the how comparison goes on into the integer thing, and but other than that, quite nice. Still a little bit shocked that I couldn't think of that how it would work recursively, but we'll worked with a stack here, so it's obviously it makes sense that it obviously will work recursively as well, and pattern probably won't be that different, but I actually like it more that way, even though, yeah. Also put a lot of checks in, which, well, most of them didn't fire. Only this one exploded. We would have seen that here as well. But yeah, also good if I don't need them, right? So thanks for joining in today, and see you tomorrow. Bye bye.